Alright guys, let's do problem number 3. We are still solving systems of 3 equations with 3 unknowns. Now the last problem we did, problem number 1, we solved it with the elimination method. But this time we're going to do substitution. Yeah, because look, the first step of substitution is to get one variable by itself. Now look at this x right here. All right, there's no y, there's no z. It's just 3x equals negative 12. So you can imagine how easy it's going to be to get this x by itself. So it would be silly to try to do this problem by elimination when it would be just so easy to get x by itself. So let's go ahead and do that. So if we get x by itself, okay, so what we have here is we've got 3x equals negative 12. So of course we're going to divide both sides by 3. Alright, so that's going to give us x equals negative 4. So already that is one of the 3 variables we need. Now for the substitution method, you take the first variable you find, and you substitute that into the other 2 equations. So here are the other 2 equations. We've got this equation right here that I'm going to mark in blue. And I'm going to copy it here. So we've got 2x minus y plus 3z equals negative 1. And then we've got the other equation, which I'm going to mark in red. And that equation is 3x plus 4 minus z is equal to negative 7. Okay, so let's take this x value that we found and let's plug it in to both of these equations and see what happens. So I'm going to put my x value here, and I'm also going to put it here. Alright, let's start with the blue one. So this is going to become 2 times negative 4 minus y plus 3z is equal to negative 1. Okay, so that's going to give us negative 8 minus y plus 3z equals negative 1. So let's go ahead and add 8 to both sides. So that's going to give us negative y plus 3z is equal to 7. Okay? Alright, so that's as far as I can go with that so far. I'm just going to put a little box around that called the blue equation. Now let's see what happens with the red equation. So this is going to become 3 times negative 4. Okay, again from the x value, plus 4 minus z equals negative 7. I'm already seeing, see this one didn't even have a y in it. There's no y in this equation. So z is going to be my only variable, so that makes things easy. So this is going to be negative 12 plus 4 minus z is equal to negative 7. Putting these together, that's going to make negative 8 minus z is equal to negative 7. Let's add 8 to both sides. So that's going to give us negative z is equal to 1. Okay, dividing both sides by negative 1, which will have the effect of changing both of these signs. So that'll give us z equals negative 1. Okay, so that is a second variable. So now we have x and we have z. All we need is y. Well, I mentioned we have z now, so let's take this z and plug it back in. Now, if I wanted to, I could take x and z and plug it into, for example, this middle equation. All right, I could plug in x here and z here, and then that would just leave y. But I could use this blue equation. And so now I have z, so I could just take z and plug it in right there. So to me, that's going to be easier, so that's what I'm going to do. So getting back to the blue equation, so this becomes negative y plus 3 times negative 1 is equal to 7. So that's going to give me negative y minus 3 is equal to 7. I would add 3 to both sides. Okay, so that's going to give me negative y is equal to 10. And again, I need to change these signs. So technically, I am dividing both sides by negative 1. But that will have the effect of changing both signs. So that's going to be y equals negative 10. Okay, so that's it. I have all three values. I have x, y, and z. If I wanted to record my final answer as an ordered triple, I would put it in the form x, comma, y, comma, z. So in that case, the answer would be negative 4, comma, negative 10, comma, negative 1. Okay, so we just did number 3 by substitution.